Let's talk about decision trees. So you've got a decision to make. Take the road on the left, take the road on the right. Which one do you take? And Decision trees can help us make that decision. Decision trees are pretty simple in and of themselves. They are just a visual, kind of graphic representation of this decision making process. They're just one of many of our decision making tools in our toolbox. So we can use this in certain situations and just to help us make a decision and helps us calculate. So this is a quantitative tool, helps us calculate which decision is, say, quote unquote, best from our available options. So you might have decision to make, you might have two options, you might have eight options. Which one is kind of quantifiable, um, is the best from that standpoint. Now we're going to employ decision trees when the future is kind of uncertain. There are all these little contingencies. If I do X and then Y, Z, B, and Q happen or could happen. I don't know if they're going to happen. They might happen. So we've got these difficult decisions to make. We've got this kind of uncertain future. We've got this uncertainty about these contingencies if I implement option A versus option B, and these options kind of have these unclear ramifications. So we're going to try to quantify as best as possible and kind of lay it all out in this visual way. When sketching out our decision tree, we'll see three kind of distinct parts. There'll be a square, that's our decision. Which way do we go? And again, there might be one option, or not one option. It might be two options, might be three or four or five or 12 options, but they all kind of come out of this primary decision, the decision we're going to be making. You'll see circles, and those are your probabilities. Those are your chances. So if I make, if I go with option A, there's a chance that it could succeed, chance that it could fail. So those are our chances. And then we've got coming off of all of those, all these branches. So, we're thinking of an actual tree. We've got the trunk, that's our decision. And then we've got these branches coming off of these kind of probability chance circles. If that didn't make any sense whatsoever, here is a decision tree, pretty kind of simple decision tree laid out for you. We've got this kind of square area, and I've got, mobile phone production. That's my decision. Do I go with technology A or technology B? So I can go either way on my decision, and then there's some chances, these circles, right? So if I go with technology A or technology B, there's a chance that I could have a high profit. There's a chance I could have a low profit on each of these, and then we'll get into the numbers here in a second. But this is kind of the basic layout. Same thing here. We've taken the numbers out for you, but this kind of square rectangular area, that's our decision. I've got some patient with a disease. Do I go with treatment A, treatment B? I've got drug A, drug B. Each has a chance of survival or death. Yay. If my patient survives drug A, I keep giving drug A, and then what is the outcome, right? Maybe what are the side effects here? Same thing with drug B. So I've got these chances. I've got a decision to make, and then when I make this decision and go with plan B, I've got I've got a chance that my patient may die or may survive. If they survive, what are the side effects to that drug? And within that decision tree, we'll start kind of filling in these parts and these numbers. One of these parts is we'll call it the payoff. So payoff can be positive or negative. It's what happens, what do you get or what do you lose by making this decision. So it can be positive, it can be negative. We can gain money, we can lose money on decisions. So payoff might be money, payoff might be some other quantifiable outcome like lives saved, or maybe clients served. So it doesn't have to be money. More often than not, it is money. But as long as it's quantifiable, as long as it's measurable, the payoff can be measured. So your payoff is your outcome. What happens with this decision, or what do you expect to happen with that decision? The other one's going to be your probability, and that's the chance of that occurrence happening. And your probabilities, we're going to express this from 0 to 1, bounded by 0 on the low end, bounded by 1 on the high end. So if we say there's a 50% chance of me going out to dinner tonight, well, that 50% chance that equals 0.5. So as we are kind of working through these decision trees, you're not going to see 50%, you're going to see 0.5. You're not going to see 10%, you're going to see 0.1. If it's 13.5%, you'll see 0.135, right? So bounded by 0, bounded by 1, but the probability is just the chance of that thing, whatever that thing is, chance of that thing occurring. Then from those two, payoff and probability, we're going to calculate expected values throughout our decision trees. And your expected value is just your payoff multiplied by that probability, that chance of that thing occurring. So if it doesn't occur, if there's a 0% chance, 0% chance, excuse me, 0% chance of me winning the lottery, I could win $5 million, but if there's a 0% chance, I get zero money, right? So this is just the expected value, expected monetary value. So if I have a 30% chance of getting $500, all we do is multiply the payoff by the probability. 500 times, again, 30% is 0.3. 500 multiplied by 0.3 is 150. So my expected value from that situation is $150. Then we can also kind of combine things, right? It just doesn't have to be a one-off. So maybe I have a 30% chance of gaining $500, but I also have a 10% chance of losing $1,000, and then a 60% chance of just nothing happening. Um, all of these probabilities are going to have to add up to 100%. In that first example, a 30% chance of getting $500, but the other 70% was a no change. But here we're adding in a 10% chance of a $1,000 loss, and then backfilling that other 60% of no change. So what do we do there? Right, so I've got my payoffs and I've got my probabilities, but I've got more than one. Well, I just add them together. So I've got a 30% chance of getting 500, so that's 500 multiplied by 0.3, and then I add that to my 10% chance of $1,000 loss. So add in a negative $1,000 times 0.1, and then a 60% no change, that's 0 times 0.6. That ends up being 150 plus a negative 100 plus 0. If we add all that together, we get 50. So $50 out of that scenario. And that's what we're going to be doing in these decision trees. It might be pretty simple, just one payoff, one probability. Might be multiple payoffs, multiple probabilities. They're usually multiple payoffs and multiple probabilities. So we're going to be adding all of these together and kind of working piecemeal through these decision trees. And now you're probably thinking, well, I don't know all the probabilities of future events happening. If you did, go buy a lottery ticket, right? You don't know all the payoffs or the exact payoffs. We're estimating all of these things. And what we can do, we can come up with this decision tree, work our way through this decision tree, and then afterward conduct these sensitivity analyses. And what the sensitivity analysis does is we take these estimates and we just adjust them up or down, a little bit, a lot. If you're really uncertain about a number or probability or a payoff, we can adjust it a lot. We can adjust it a little bit if you're pretty certain about it. So we're adjusting payoffs, we're adjusting probabilities, and we've got our kind of our base case decision tree. That's kind of our best estimate. But then we're going to calculate some best case scenarios. We're going to calculate worst case scenarios. We're usually more interested in the worst case scenarios. So we're going to adjust numbers up and down and see kind of how robust that base case was. Our initial decision tree finding, how robust was that? So if my numbers shift a lot, there's a lot of uncertainty there. If they don't shift a lot, they just shift a little bit, we can be pretty certain that the decision that tree kind of pointed us towards is a pretty solid decision. Now, before we go any further with decision trees, there are some limitations to a decision tree. We just don't whip this out whenever, wherever we want. This is one of many decision-making tools, just one of those tools in your toolbox to be taken out when and where appropriate. But there are issues of uncertainty. We are estimating a lot of things. I don't know what's happening in the future or going to happen in the future, so there is a lot of uncertainty there. And then there's the issue of bounded rationality, where we can't account for every little hiccup, every little chance of something happening. So we're going to include everything that we can think of, that we think is important. Important inputs for this decision, but we're always going to be missing something. We're always going to overlook something, or something's just going to happen that we never in a million years could have predicted. All right, now let's go through a simple example, and we'll make it non-medical, non-EMS, anything. I live in a small town here in the mountains. Should my town buy its own snowplow? And if it buys its own snowplow, it can charge us residents a little bit of money to run that snowplow. So when it snows, every time it snows, they can charge us a little bit of money. Well, I've got a payoff, right? So we're looking at payoffs. We're looking at probabilities. So I've got a payoff. Well, my payoff is going to differ based on the snowfall. If my town is charging us per snow event, there's some profit to be made there perhaps. So if the season's snowfall is heavy, there's a chance of a $7,000 profit. If the snowfall is moderate, or let's just say normal, um, there's a $2,000 profit that we're estimating could be made. But if the snowfall is light, if there's hardly any snowfall this year, we could lose $9,000. Then alongside our payoffs are going to be our probabilities. Well, there's a 40% chance that there might be a heavier than normal snowfall this season. That's what the meteorologists are calling for. And then there's a 30% chance that there is a moderate snowfall, and another 30% chance that there's a light snowfall. Again, I'm going to double check and make sure all of these percentages add up to 100%. They do. If they don't add up to 100%, you're missing something. So go back and double check yourself. But I've got my payoffs. I've got my probabilities. Now let's sketch out this decision tree. All right, so we're going to sketch out a decision tree for this plow decision. Do we buy a plow? Do we not buy a snow plow? And we're going to work our way left to right, and then back again, right to left. So let's just sketch out the bare bones of this decision tree first. So I've got my decision to make, right? So I've got my square up here, right? Maybe I buy a plow, right? And down here is my other decision, and down here is just, well, no, we don't buy a plow, right? And please excuse my horrible handwriting on this techno board here. Well, with my no plow, well, that's pretty easy. That's not going to get me any money, right? That's not going to get the town any money. Nothing's going to happen. No change. So that's kind of a non-issue, right? Up here, well, here's one of my kind of decision points, right? Here's one of my, or not decision point, excuse me. So the squares are kind of our decisions, so plow, no plow. Our circles are kind of our chance areas. So here, well, we had kind of three chances. So I'm going to draw three chances here, and right, and here we have a snowfall that's heavier than normal, or pretty heavy. Here we'll just say snowfall is moderate, and then there's a third chance, third probability that snowfall was light. So if I don't buy a plow, right, why am I not writing these down here as well? Well, if I don't buy a plow, then this doesn't matter. If I do buy a plow, then snowfall does matter to to my decision. Well, remember, there were different profits here. So if snowfall was heavy, we'd make an estimated profit of $7,000. So we're going to write that right next to there. If snowfall was moderate, we'd have an estimated profit of $2,000. And if snowfall was light, we'd have an estimated loss of $9,000. So now I've put in my payoffs. So again, we're going left to right. I've put in my payoffs. Now let's put in on our probabilities. Well, for heavy snowfall, there was, there's a 0.4. We say 0.4 is a 40% chance of there being heavy snowfall. For there being moderate snowfall, there's a 0.3% chance. And then for light snowfall, there's also a 0.3% chance. There we go, that looks a little better. Well, now what do we do? Now we've gone left to right. Now I want to go right to left and see if which decision is better, to buy a plow or to not buy a plow. So what we're going to do is we're going to calculate the expected values here. Right? So 7,000 times 0.4, we get 2,800 there. So if there is heavy snowfall, there's an expected value of $2,800. Moderate, 2,000 multiplied by 0.3, we get 600. For our light snowfall, we've got a negative $9,000. So don't forget that negative. That's a loss. So anytime we see a loss, that's going to be a negative number. So negative 9,000 multiplied by 0.3 is a negative 2,700. So what do we do now? We're going to go right to left, and we're just going to add all of these up because they're all within the same decision area. So we're going to go right to left. We're going to go in that direction, and we find that if we add those together, we end up with a positive $700. And then, okay, well, what decision do we make? Do we buy a plow? Do we not buy a plow? Well, according to this decision tree and our estimates here, we are comparing a positive $700 versus $0. So which one is greater? Well, it's the plow, right? Buy the plow. So we're going to say nope. We're going to go with the plow in favor of not purchasing a plow because there is this benefit to the plow based on our decision tree and based on our estimates. All right, now so we had this $700, right? But I've erased all the probabilities because we're going to do a quick little sensitivity analysis. Instead of there being a 40% chance of heavy snowfall and a 30% chance of moderate snowfall, let's change those around just a little bit. I'm not going to change moderate snowfall, so that's still going to be a 30% chance, 0.3, right? And then that'll equal $600. But we're going to change heavy and light because you know what? We still live in North Carolina. We still live in the South. So maybe the chance of light snowfall instead of 30%, let's just bump it up a little bit to 40%. If we do that arithmetic, if we do that, so payoff multiplied by your probability, we've got a potential loss of $3,600. And then again, all these probabilities need to add up to 100% or just 1. So right now we're up to 70%, so we're dropping our heavy probability to 0.3. And if we do that, then the new 7,000 times 0.3, $2,100. Again, we're going to add all of these together. And what do I have now? Instead of 700, let's take that away. Instead of that, if I add these all together, now I've got a negative $900. So in my base case scenario, I had a positive 700 and it looked like we should buy the plow. Well, now all I've done is changed one little thing by just a little bit, right? Change this in the sensitivity analysis just by a little bit, and now it looks like, well, no, the town should not buy a plow. So that's why we do these sensitivity analyses. Kind of change it around just a little bit. Based on our best guess, our best estimates. And if we just change it a little bit and then suddenly the decision is completely different, well, you know, then we get into, should we take the risk to buy this plow or not buy this plow? Again, pretty simple example, non-medical, non-EMS, just to give you an idea of what his decision tree looks like and how we can do just a real quick, easy and dirty decision or excuse me, sensitivity analysis. These decision trees is a pretty simple one. They can branch off. There will be, multiple kind of those chance probability points. You'll get into those in your assignments. But this is a pretty simple one to see how this is set up and how we get to the end decision with our decision tree. As always, if you have any questions, comments, concerns, or cuss words, please feel free to let me know.